All right, guys, here's a quick video just going back over the review we did in class in case you want to hear it go through again. We'll just kind of go through this real quick. Just FYI, the pen I usually use for this on the little iPad is not working well, so if the writing wasn't bad before, if it's really bad, I apologize ahead of time. Flip. All right, so determine, we'll get back for a second. Determine if each set of segments can create a triangle. Very simple idea. You need the two smallest numbers, add them up. If they're bigger than the third side, yes, it's a triangle. Here, make sure they're in order because it does have to be the two smallest ones. The reason is, like if I started with 4 and 10, 10 is already bigger than 6. You know that. But it has to work for all three pairs, and the only one that might not work is the two smallest. So 4 plus 6 is 10, sorry. That equals 10. Let's see, the pen's messing up a bit, sorry. Can they be equal to the third side and be a triangle? No. So it has to be bigger. If it's equal or less than, not a triangle. Number 2, Kristen has 2 sticks that are 6 feet and 8 feet. She wants to make a triangle. What is the range of possible values that the third side can be? So, possible third side of a triangle, real easy. X in the middle, less than on both sides. It's a range. The small number, you subtract the 2 you're given. 8 minus 6, that's 2. The big number, you add, 8 plus 6 is 14. And so the third side of a triangle can be anything but bigger than 2, less than 14. It's not just one set number. Okay, but that's all you got to do for that. 3, an isosceles triangle WXY. The interior angle W measures 100. Find the other two sides. Isosceles triangle, 2 sides match. So if this is 100, they want to know what these two angles are. Well, first of all, if it's isosceles and these sides match, these angles also match. So you can call them both x. Now, what do 3 angles of a triangle add up to? 180. So literally to solve this, you can do x plus 100 equals 180. These two combine to make 2x. 180 minus 100, we can kind of do 2 steps in one, is 80. So divide that by 2, and each side is 4. So just remember in an isosceles, these two angles have to match. Even if only one has an angle, like if x was written there and this wasn't, you can't just do 1x and 100 equals 180. Oh, sorry, I'm erasing that. Because you need 3 angles in a triangle. So even if it's blank, like this has an x but that one doesn't, you got to put it there. So this will match that no matter what's there. 4, a student wants to inscribe a circle inside of a triangle. What segment should the student construct to locate the in-center? I'm going to also add with this the set of the matching. You need to know the segments and what goes with them. Okay, in-center is where 3 angle bisectors meet. Okay, and it is the center for a circle that will go inside a triangle. It'll be like this, and it'll touch all 3 sides. I drew that kind of quick. Angle bisector on that one. If 2 sides of a triangle are 712, what are the possible lengths of the third side? Same thing as question 2. X in the middle. 12 minus 7, 5. 12 plus 7, 19. You don't always have to write the plus and minus. I do that when I go over problems so you can see it. But I mean, it's really that simple. Which angle is smaller, 1 or 2? Again, you'll notice that AB and DC are the same, and obviously they both use BD. So this angle here and this angle here, 1 and 2, both use the same side lengths, but you'll notice that this one's across from a 38, this one's across from a 43. So if the sides are the same, but they're across from different lengths, that means the bigger angle is the one across from the bigger side. So if I want smaller, which one's across from the smaller side? Angle 2, because it's across from 38. 7, J constructed a line segment from each vertex that was perpendicular. Oh, sorry. Let me see. To the line containing the opposite side of the triangle. Okay? So if you look at your segments, there's 2 possible that are perpendicular. One is the perpendicular bisector, but that goes through the middle. It doesn't have to touch the vertex. If I'm going from the vertex perpendicular to the other side, that is the altitude, which is like a height. What point of concurrency does the altitude give us? Orthocenter. Again, just got to memorize those, go over them. All right, on to page 2. The test is only 10 questions. It's not very long. All right? So I just said a second ago that it's 10 questions. It was originally 10 questions. I think it's like 13 now, but that's because we kind of broke one question up into multiple parts, and you'll see it's not that bad. What is the altitude of ABC? So altitude, like we said a second ago, goes from an angle to the opposite side perpendicularly. On here, what am I looking for? There we go, sorry. That would be right there, from B to D, right? Well, okay, goes from a vertex, like we just talked about, to the opposite side perpendicularly. The second part is, what is the median of the triangle BDC? And what you got to be careful of there is BDC is this triangle. So it's not a median of the whole thing you're looking at. Let me erase all this so I can better outline it. It's just this part right there. Median goes from an angle to the middle of the opposite side, and that would be right there. Huh. Told you this pen, sorry. But that's DF. From the middle, from the vertex to the middle of the opposite side. That's a median. Nine, SU is a perpendicular bisector. So SU is perpendicular, you see it there. They match there. Find the length of X and TU. I'm going to turn this and see if this makes this a bit easier. Like 2 problems left, that's fine. Maybe. So the key there is that TU and UR are congruent. And so because they're congruent, you're going to set them equal. 2x plus 24 equals 5x minus 30. So you do some algebra. Minus 2x minus 2x. 24 equals 3x minus 30. I'm writing real big, but it's okay. We're going to have to add 30 to cancel here. You get 54 equals 3x. And divide by 3, x is 18. So there's the x part. TU is 2x plus 24. So you're going to plug it in. 2 times 18 plus 24. You have your calculator. Sorry, that's supposed to be a 4. 2 times 18 is 36. Plus 24 is 60. Point U is the centroid, ME has a length of 21. Find EU and UM. So the centroid is where three medians meet. Centroids divide each line not in half, but into a 2/3, 1/3 ratio, which means the longer part is twice as big. For this problem, what we'll do, EU is going to be the longer part. So EU is 2/3 times 21. You do have to multiply by the fraction. You have your calculator, that should make it easier. But even if not, if you multiply straight across, 2 times 21 is 42, divided by 3 is 14. So EU is 14. And then UM, there's two ways you can find that. Remember in the problems, that should be twice as big as the other one, so it should just be 7. Using the method we did for EU, though, you can actually find it by saying 1/3 times 21, because that's the smaller piece, is 21 over 3, which is 7. So either way, that works. Hope that was helpful. Look at this stuff. Look at the matching ones. That'll be helpful. Good luck on the test tomorrow.